Polynomial long division was always quite arbitrary and unsatisfying to me because the algorithm just was randomly explained, like you divide the x cubed by the x and then you get x squared and you multiply it, and it's just very random. Like, why don't you divide the x plus 2 into the x cubed, or x plus 2 into x cubed plus 5x squared? Spoiler alert, you actually kind of do that. It's just like not very well explained. But basically, for that reason, I want to give you an idea for a visual way of doing this. It's not, it doesn't work every time, although it can, but in this video, I just want to give you the idea, and then in a later video, I want to show you how you can use this idea for any polynomial, and then I want to also show the connections between this idea and the algorithm that we learned, and some connections with regular long division, just kind of bring it all together and make it all make sense, hopefully. So in this video, again, is just the idea, so I want to get into it. So the only thing you need to know is how regular division works. So when you kind of learn it for the first time, 6 divided by 2 is kind of like how many times can we take 2 away from 6? So we can take it away once, twice, 3 times. So that means that 6 divided by 2 is 3, because we can take 2 away from 6 3 times. The only other fact you're going to need to know for this is that you can split up division like this. If I have 6 plus 3 over 3, that's the same as 6 over 3 plus 3 over 3. And you'll see where these two facts come in handy. I'm just going to put them in a little box there. And now we're going to move on to the polynomial. So for x cubed, I just want to draw this out. So the x cubed terms, I'm going to represent those by drawing cubes, just because that's what they physically represent. X times x times x. It's like if they're all side lengths of a cube, you're multiplying them together, you get the volume. X times x, that's like getting the square, because you have a length of x and then you stretch it out by x units. And we have 5 of these x squareds. 4 and 5. The x I'm going to represent by a line, because it's like you just have a line of length x. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then x to the power of 0 is just the constant, like 8. That has no dimension, so I'm just going to draw them as dots. 1, 2, 3, 4, 5, 6, 7, 8. So it's not stretched out by any amount, whereas this one has a side length of x, then x squared, the side length of x is stretched out by x units, giving us a square, and then the square is stretched out by x units, giving us a cube. Again, you can draw these with any shapes. The shapes don't matter. It's just to kind of separate them from each other and show them as distinct objects. And then what we're dividing this by is, I suppose we have a dash, x, and then we have 2 dots. So, which is x plus 2. That's what we're dividing by. Okay? So we basically need to see how many times can we take away x plus 2, the dash and the 2 dots, from this big thing here. So the first thing that you might think to do is, well, we can easily take this x plus 2 away from all this stuff. So let's just do that. How many times can I take away a dash and 2 dots from this stuff? And remember, we're allowed to separate them, because this is a property of division. So let's just do that. So a dash and 2 dots. So we have a dash gone and 2 dots. That's once. A dash and 2 dots twice. A dash and 2 dots 3 times. A dash and 2 dots 4 times. So that clearly goes in 4 times. Now we're going to have to take away again. So we're going to do plus, and we're going to have to take away something else. So let's see what else we're going to have to take away. So we can't really do anything now because we have dots and dashes, but up here we have squares, dashes, and cubes. So I want you to have a think, what could we multiply this by? So initially we multiplied it by 4 to get rid of all the dots. What could we multiply this by now in order to kind of work in terms of squares and dashes? So right now we have dashes and dots. What could we multiply this by to work in terms of squares and dashes? Pause the video and have a think. Well, if we multiply each of these by an x, so we're multiplying the thing we're dividing by an x. So remember, this dash is a line of length x. If we stretch that out by x, if we multiply it by x, we get a square. And if we have a dot and we stretch that dot out by x units, that gives us a dash of length x. So now our next term is going to be multiplied by x, because it brings us up to the correct dimensions. And now we see how many times can we take this thing away from this thing. So this is our x plus 2, the thing we're dividing by, but it's just multiplied by an extra x. So how many times can we take it away? Well, it's a square and 2 dashes, so a square and 2 dashes once, a square and 2 dashes twice, a square and 2 dashes 3 times. So we can take it away not just 3 times, because that would mean taking away dashes and dots. We're taking it away 3x times. Again, the x is there to bring it up to the correct dimension. Now we just have cubes and squares left over, so you might be able to guess, but I want you to try to guess, what could we multiply? So this is what we're dividing by, it's just x plus 2. What could we multiply this by so that we're working in terms of cubes and squares? Well, if we multiply this by x twice, Well, multiplying by x once, again, brings us up one dimension. So stretching that line out by x gives us a square. And then, same with the line, sorry. And then, if we stretch it out by x again, so we stretch this square out and by x units, that'll give us a cube if we stretch it out. And then if we stretch out a line by x units, that gives us a square, which is x by x. And now we can see, so our next term that we're going to take away, so we're taking away 4, and we're taking away 3x, and we're taking away, and this time we're going to do something with x squared. So how many times do we take this away then? Well, clearly we just take it away at once, because we have 1 cube, 2 squares, 1 cube, 2 squares, so we take it away 1x squared times. So I thought it was always very kind of confusing. What does it mean that, you know, this whole thing is equal to this? This means we can take this away 4 times, and we can take it away 3x times and 1x squared times. That always kind of really went over my head, but when you think about it this way, it really makes sense what it means. That taking away 1x squared times just means we're taking away the thing we're dividing by, but we're kind of changing the dimensions of it to be in the same dimension as the x cubed and the x squared. So I thought this was really satisfying. You might be thinking, how do we deal with negatives? How do we deal when it doesn't go in evenly? I will do a video on all that. In this video, I just wanted to give you the idea. And then I also want to show the connection between this and the actual kind of way you normally do it, where this divides into this, how many times, multiply it by this, write it underneath. I want to show the connection and how this method explains how that works. And then I also want to show all the connection of all of this to regular long division as well. So I hope that was interesting. Please leave any feedback or thoughts or ideas in the comments. And yeah,